It's not going to be anything new. We've already started this while we were in school, but we only talked about it very briefly. So now I just want to give a video to allow for you to see it and always refer back to it if you ever needed it. But this video, we're going to then discuss proportions versus tape diagrams. And now remember, as I said before, I don't really care which one you use. You will pick the one that you think is best for you. If you think proportions is the easiest for you to do, then go ahead and use proportions. If you think tape diagrams, then go ahead and use tape diagrams. Me personally, I always set up a proportion, but really it doesn't matter whichever one you want. There is one thing that is very important no matter which method you choose, and we'll talk about that in a second. So our learning objectives for this video is the first thing is determine which method you should use when solving problems, whether if it's going to be proportions or tape diagrams, right? So we are going to go through some examples. And in these examples, some of them are set up for us to use tape diagrams a little bit easier, and some of them are set up for us to use proportions. So sometimes you might see a problem like, okay, I'm going to attack this with a tape diagram. Sometimes you might see it and say, I'm going to do it with a proportion. So you will determine which one you think is best when using each problem. Then this is the most important part. No matter which method you use, you must create an equation. If you do not create an equation, then you're going to not get credit for one of the standards that you will be tested on. Because the standards are solving these problems, and then the other standard that is going to be is creating an equation to solve. All right? And then so you will create an equation using proportion or tape diagram. So no matter which way you do it, you will create an equation. I'll show you again in this video what those equations may look like. And then the third thing is, I've already said, I don't care which one you use, find which one is most comfortable for you to use, and you can use that every single time. So no matter how the problem is, whether if it should be or it might be easier for tape diagram or easier for proportion, both of these methods work every single time. So it's completely up to you. Whichever one you feel most comfortable with, you can go ahead and solve. All right, we're going to talk about proportions again very briefly, and then we're going to move on to solving some problems. But before we do that, just let me start this number 2, because you must, no matter what, create an equation when you're solving these problems. So we've talked about what a proportion is, but just again, real quick to go through it. A proportion is a statement that shows that two ratios are equal, right? So when I write this statement here, 2 over 4 is equal to 8 over 16. I'm telling you that it is a proportion because I'm giving you this equal sign in between. And remember, ratios can be written as fractions. So by saying that these two ratios are equal, that is telling you that this is a proportion. All right, so we're going to go through a couple examples. I'm going to split the screen in half as to how you can show that these ratios are in fact equal to each other. And using these two methods are how we can go ahead and solve a proportion later on. So let me give you that one, and let me give you another one. Let's do 10 over 15 is equal to 8 over 12. All right, so one way that we can do this, and we've already talked about this in class, is to show that these are in fact equal. We can look at our numbers, and the first numbers I can look at is just my numerator. And I can say, okay, 2 and 8. Well, 2 times what gives me 8? And I know that that's going to be 2 times 4. So since these are equal, the bottom, the denominator, will also hold true, meaning that if I multiply this denominator by 4 as well, then it must give me this other number, which it does. 4 times 4 gives me 16. All right, so one way that we can show that they are in fact equal to each other and a proportion is if we can just look and see, well, what number times our numerator gives us the other numerator. In this case, it was 4. So then that means if we multiply the other number by 4 as well, it must give us that denominator, which it does. So it shows you that they're in fact equal. And then the other way that I told you before that we can do this is we can do our x method. Remember, throw your x up. So to do that is we will multiply the one numerator times the opposite denominator, and then we will multiply the other numerator by the other denominator. So if we multiply these together, we will now have 10 times 12 is equal to 15 times 8. Well, 10 times 12 is equal to 120, and 15 times 8 is also equal to 120. So since the product of those two cross multiplications is equal, it tells us that the proportions are equal. Right? And now we can use both of these two methods when we're solving these problems, and I'll show you that throughout this video as we're solving proportions. Right? This is the one that I would highly suggest that you use every time, just because numbers aren't going to be as easy as this. But it doesn't really matter how you go through and solve it. All that matters is that you are setting up your proportion. All right, so there's a few problems that we're going to go through. Let's go ahead and solve these now. First question that we're going to do is the ratio of boys to girls is 3 to 2. If there are 12 boys, how many girls are there? So when I'm determining personally which one I'm going to use, I first look at my ratio, and it's 3 to 2. So I see that they're small numbers, so this will be easy for me to draw the boxes when I do this. If it said 300 to 219, I'm not going to draw the boxes for that because I'm not drawing 300 boxes out. So then I look after that to determine which method I'm going to still use as I look and see, okay, they gave me the number, the ratio for boys, and they gave me how many total boys I have. So they gave me that the ratio was 3, and there's 12 total boys. And since I know that 3 divides evenly, or 3 goes into 12 evenly, then I'm going to go ahead and use this tape diagram. If it didn't go into it evenly, then maybe I wouldn't use a tape diagram and I'd use a proportion. It really wouldn't matter at that point. You can still use any of the methods that you want. But here I'm going to go ahead and draw my boxes. I have boys to girls. And then it tells me that the boys total is 12. So I know that these 3 boxes is equal to 12. And we've talked about already that all these boxes represent the same number. And our goal is to solve for one of the boxes. So now I see I have 3 boxes, so I can set up my equation. 3b is equal to 12. This is something that you must do. Without setting up your equation, you're not going to get full credit for all the standards you're being tested on. I will then divide each side by 3 to isolate my variable. Remember, what's being done to it? We do the inverse, multiplications, inverses, division. So now we get b is equal to 4. That means that every single one of these boxes is equal to 4 people, or it represents 4 people. So if I want to solve for how many total girls there are, I can do 4 plus 4 since I have the 2 boxes. Or what I would suggest is that you do 4 because that's how much each box represents, and we have 2 of them. 4 times 2 is equal to 8. So we have 8 girls, or 8 total girls. All right, so you see, when I was choosing to do the tape diagram for this, I saw that one, my ratio was small, meaning I can draw it. And then the other thing I saw was that I would be easily able to divide this total boys by my boys, my ratio. If this ratio said 5, maybe I wouldn't do that, and I'll explain that on the next problem. All right, so let's go ahead and go to the next problem where we're going to set it up using a proportion. All right, so for this next problem, it says Mr. Johnson was paid $190 for a job that required 40 hours of work. At this rate, how much should he be paid for a job requiring 60 hours of work? So when I look at this, remember, our ratio is comparing 2 different things. So I'm not going to compare the hours to each other because that's not setting up a ratio. I'm going to compare the hours with the money that we have. That will be setting up our ratio. And when I see 190 and 40, 1, it doesn't divide into it evenly, and 2, 190 is a really large number, and so is 40. So if I'm going to draw these boxes, even if I reduce it, I'm still going to draw 19. So I'm going to set up a ratio. And a ratio I'm going to set up is 190 over 4. So the one thing that you have to be aware of is you must stay consistent. So the ratio I set up was money over hours. So that means when I set up my next ratio, that it is going to be money over hours as well. So when I go ahead and set up the next one, it says how much should he be paid for a job requiring 60 hours of work? Well, we don't know how much he's getting paid. That's what we're solving for. So I'm just going to go ahead and I'm going to put P for being paid. And then we know that he is working 60 hours of work. So I'm setting this up, and you see it follows the same exact way as the other one. We have money over hours. So money over hours, right? So now what we need to do is I'm not going to set up the tape diagram. I'm going to cross multiply to solve this one, right? So that means I will multiply this 40 and this P. So I will get 40 times P, and this 190 times 60. All right, so now let me go ahead and rewrite this. So I have 40p is equal to 11,400, and then I will divide each side by 40. So that way it's being multiplied right now to the p, so I will isolate the p by division. And I will write the answer over here. So p is then equal to 285. So then that means that he will be paid $285. $285. All right, so I didn't use a tape diagram for this one because it was going to give me a really large ratio and also a number that wouldn't be able to divide evenly into. But that's really up to you with how you're going to go ahead and solve this. You could have still solved this one using a tape diagram. But I showed you the two different ways, proportion, and I showed you tape diagram. Now I'm going to go through another example where instead of cross multiplying, I'm going to go through two more, but instead of cross multiplying, you can go ahead and use another method of solving when you have your proportions. All right, so let me go ahead and show you that one. All right, the next one says, Mary has saved $17.50 in the past 3 weeks. At this rate, how much will she save in 15 weeks? So once again, I'm not going to set up a tape diagram because one, I'd have to compare the money with the weeks because remember, our rates are comparing two different things. It's not going to be weeks to weeks. And if I do 17.5, that means I'm going to draw a half of a block. It's just going to be messy. So I'm going to go ahead and set up my ratio. So I'm going to do 17.5 or 50 over 3. All right, so now, once again, you just must stay consistent. I did money over weeks. So that means when I set up my next ratio, I must do the same thing. So I'm creating a proportion here, so it's going to be equal to, and I don't know how much because they're saying how much will she save. So I'm going to do M for money over 15 weeks. So M over 15. So now I could go ahead and cross multiply this and it will be perfectly fine. Can do that for sure. But remember, another way that we know is that if ratios, or I'm sorry, if ratios are proportions, then we know that if we see here that 3 times what number is equal to 15, well, 3 times 5, that's easy for me. I can go ahead and use this to figure out what the next number is going to be as well. So I can go ahead and just do 17.5 or 50 times 5 is going to be equal to my M. And that will then give me 87.5. So that means that the amount of money that they would save is $87.50. Right? Even if we were to go ahead and do our cross multiplication, we would have cross multiplied here. Let me use a different color. We would have cross multiplied. We would have got 17.5 times 15 is then equal to 3 times M. 17.5 times 15 will give me 262.5 is equal to 3M. I would have divided each side by 3, and it would have given me 87.5. All right, so no matter what, it would still give us the exact same answer. But if you see, hey, I know that 3 times 5 gives me this 15 here. That means all I need to do to this top number is multiply it by 5 as well. Sometimes it will work out like this. And sometimes that'll be awesome. It'll be great because you get to finish this problem a lot easier and a lot quicker as well. But if you cross multiply every single time, you will always get the answer. You're not always going to be able to figure it out like this, like we did on this problem, but sometimes it might. All right, there's one more problem, and then that will be it for this video. All right, just to practice again our cross multiplication. First, I'm going to set this up. It says if 2 pounds of meat will serve 5 people, how many pounds will be needed to serve 13 people? So once again, here, none of these numbers are going to divide into anything evenly. So I'm going to go ahead and set up my ratio of 2 pounds of meat for 5 people. So I did pounds over people. So that means that I need to go ahead and do the exact same ratio when I'm doing my next one for this to be valid. If I did people over pounds, I'm not being consistent anymore. I'm comparing them in 2 different ways. So I don't know how many pounds, so I'm just going to do P for pounds over top of 13 people. All right, so now we can go ahead and cross multiply. We will get 2 times 13 is equal to 5 times P. We will then get, 13 times 2 is 26 is equal to 5P. We will then divide each side by 5 to isolate that P. What we do to one side, we have to do to the other. And then this will give me that P is equal to 5.2. All right, so that will be our answer, that it will be 5.2 pounds. All right, now I'm going to show you this 26 divided by 2, but by now, hopefully you're able to divide long division. If you can't, it's fine. Let's go through it now. 5 doesn't go into 2, but it goes into 26 5 times. So we can then subtract the 25 from it. That gives me 1. And now, remember, you're never going to write a remainder for me ever again. So in order for us to continue doing this, we need to add a 0 because 26.0 is still 26, but now it gives me a digit that I can go ahead and bring down. Since I added my decimal there, I need to add my decimal here. I'll bring down the 0. And how many times does 5 go into 2? Well, it goes into 10. It goes into 10 2 times. And when we subtract, we're at a remainder of 0. I just want to add one more question because with us using the tape diagram, you would know how to solve this question when we're doing the total. but we've never set one up yet for the ratio or setting up a proportion. So I just want to go through one of these questions when we see that there's a total here and how we know how to set this up. So it says the ratio of girls to boys in the 6th grade is 6 to 7. How many girls are there if there are 364 total students? Now, if you wanted to, you could use a tape diagram for this, but I'm going to show you how you can set up a proportion for this in case it's what you want to do. So when I first see this, I see that my ratio that they're giving me is girls to boys. So that means what I might do first then is go ahead and write 6 over 7. And that means I'm doing girls over boys. But then when I go to create my second equation or second ratio, I can say, okay, well, I don't know how many girls, so I'm going to put G here for girls. And then when I look, I don't know how many boys either. It just tells me 364 total, so I might put B. Well, if you notice, I have two variables here. I can't solve an equation with two variables, and it's not going to be something that I can solve at this point. So what I would do then is I would look and say, well, what other information did they give me? And they gave me 364 total students. So that means the ratio that I created should have been girls over total, because that's the other information that they gave me. So now when I go to create this ratio, I see, well, I have 6 girls. And then if I have 6 girls and 7 boys, I can add them together to get 13 total students. So I can then make it 6 over 13. Then is equal to, I still don't know my girls, so that's still going to be G, but now I do know my total students is 364. Right? And I'm being consistent. And both of these here, I would do girls over total. If I were to try and put G over 364 here, then my ratios are not staying consistent, because then I would have girls over total here, and I would have girls over boys here. So you see, that is how we know that we are not able to solve it by creating the ratio 6 over 7, because 1, it's going to give us 2 unknowns on the other ratio because we didn't have girls or boys, or 2, our ratios wouldn't be consistent because we would have girls over boys for 1 and then girls over the total for the other. So make sure consistency is key, that however you set up your one ratio, your other ratio must be set up in the exact same way. All right, that's why I'm writing this out for you over here every single time, just to show you how I know I'm being consistent. And then from here, you should know how to solve this one at this point. So we would then cross multiply. We will then get 13 times G is equal to 6 times 364. And that will then give me, I'm going to write it up here, 13G is equal to 2,184. So I divide each side by 13. Since it's being multiplied to my variable, I undo it through division. And that means that I would have 168 girls. All right, I just want to go through because we never went through a ratio problem where we had to take the total. And I just want to show you how you can identify that that is something that you needed to do. All right, so now that's it for this video.